Hi one and all, and welcome to today's lesson on the quotient rule with circular functions. It is always good to carry on from where we left off, and the video I uploaded yesterday was circular function. It was the product rule, if you remember. Now, nice short video today because it builds on the work that we'd already done on the product rule. So, if you're wanting to see a full and in-depth video on the product rule, there is a previous one. This is just a continuation, but just looking at circular functions. The reason being is because when I taught this to my group, we actually split it up and did it in a slightly funky way. Good to see you. Now, we don't need to recap all of the recap, but what we're going to do is look at this quotient rule. Now, if you remember, for the product rule, we had y dashed is uv dashed plus uv dashed. Now, because I'm in Australia, and the sun here is strong, then I always think of UV rays. This is how I know the order for the product rule, UV plus VU. How do I remember the quotient rule? And it's always good to have little ways of remembering these things. Well, I remember that the quotient rule is given by VU dashed minus UV dashed all over V squared. Because the product rule is UV rays, then I know that for the quotient rule it's the other way, and it's minus. I know it's freaky, there's lots of ways of remembering these things, I'm sure, but this again is a shorthand notation, the way that I remember it. But the point of it is, when we are given a question, and here is a wonderful example without circular functions at this moment in time, I know that in the same way for the product rule I had to choose a u and a v, I'm going to do the same here. The u is the top and the v is the bottom. Now there is no negotiation there, that's exactly how it has to be. So knowing that, same as I did for the product rule, u is equal to x minus 1 and v is equal to x squared plus 2. So u dash, so I differentiate it, which lovely gives me 1, and I differentiate that, it gives me 2x. Now, I'm going to be very careful because with my product rule I said, oh, we can cross corners, but in this situation I have to make sure that I put them together correctly. So, we know that y dashed is equal to v u dashed minus u v dashed all over v squared. So, substituting this in, v is x squared plus 2 times u dash, which is 1, minus u, which is x minus 1, times v dashed, which is 2x. Running out of room, not enough space. Why does that rocket keep passing every time I say space? Anyway, and divided by the value of v squared. So that is x squared plus 2 all squared. Now, a word of warning, you don't have to square that out. My advice to you is leave that exactly as it is for all the rest of the question. But as I'm hoping you're aware, the top can be simplified. So I'm going to multiply that out to give me x squared plus 2 minus 2x multiplied by x minus 1 all over x squared plus 2 all squared. Now you're going to say, well, why did I not go straight to the answer? Well, I don't want to make a mistake. And so I've got x squared plus 2 minus 2x squared, but I'm now going to add 2x, all divided by x squared plus 2 all squared. Now again, run out of space. No rocket this time. And so, badly, but just to allow me to do this, I'm now going to simplify this. So that gives me minus x squared plus 2x plus 2, all divided by x squared plus 2 all squared. Now, should I leave it like that? Or a very, very good question. Can I actually factorize this top? Now, I'm going to just do a very, very quick check. I'm going to do my t method because it's quadratic and you never know, the question might be trying to trick me. So I'm going to write minus 2 on the top and I need 1 and 2. And are there any way of being able to use that? Nope. So that can't be factorized. Leaving it like this is perfectly acceptable as far as I'm concerned, but convention states, generally speaking, we don't like to have a negative at the front of the function. I'll leave it to the question to decide, in an exam, they'll tell you the format, or they probably won't even give it to you that way. But I'm just going to leave that because we wanted to give a general idea of what the quotient rule was. Now, absolutely, here are 2 examples using circular functions. So we know that we have to have y dashed is vu dashed minus uv dashed all over v squared. U has to be on the top and v is on the bottom. So now to make sure I don't run out of lots of room, let me do my u here is sine x and v is x plus 1. So v dashed is equal to 1, nice and simple, and u dash is equal. This is where you have to make sure you remember your differentials for sine, cosine, and tan. Now, I always remember that sine goes to cosine. I've got a little table, it's in previous videos, but I know that the differential of sine x is cos x. No need to use the chain rule because it's just sine of x. So this seems to be like quite a nice little question, really. So substituting it in, v is x plus 1 times u dashed, which is the cosine of x, minus u, which is the sine of x, times by v dashed, which is 1, all divided by v squared, which is x plus 1 squared. And as I said earlier, don't worry about making it any don't square that out. Just leave it as it is. It's fine. So what do we get here? I get the cosine of x times x plus 1 minus the sine of x all over x plus 1 all squared. Now again, what value would I have in multiplying this out? I could multiply it out. Does it aid readability? Because I'll get x times the cosine of x plus the cosine of x minus the sine of x all over x plus 1 all squared. I'm going to leave that as my answer. Why? Well, the reason I'm saying does it provide any value is, generally speaking, I'll multiply that if I can simplify anything. And there's nothing to simplify with cos squared of x minus sine squared x. All right? If, for example, this had been sine squared of x plus the cos squared of x, then there would be a reason, because I know that sine squared plus cos squared is equal to 1. But in this situation, yeah, is that more readable? Is that more readable? I'll leave it for you to decide. Generally speaking, as I say, the exam questions will tell you what to do. Last example, differentiate the following. I thought I would do 2. Once again, there is my u and there is my v. I've just put my trig function on the bottom, or my circular function on the bottom. Always write down the formula, vu dashed minus u v dashed all over v squared. Cross over here to do u is equal to 2x, so u dashed is nice and simply 2. V is equal to the cosine of x, and I know v dashed is, well, sine goes to cos and cos goes to minus sine. It's almost a bit of a rhyme there. So I know that v dashed is a negative of sine of x. Now it's just a sort of trivial case of banging these in the places it needs to. Bang it in like a nail on an hammer if I was a tradie, but I'm not. But I'd like to be, you never know. So v is the cosine of x times u dashed is 2 minus u, which is 2x, times v dashed. Now I'm going to put a plus there because it was minus sine of x, and a minus makes a positive, all divided by v squared, which is the cosine squared of x. Now, just as a word, I could have written cosine of x all squared, but we know that the shorthand of that, or I'll say the most appropriate way, the right way, is cos squared of x. Do a bit of simplification, 2 cosine of x plus 2x times the sine of x all over cosine squared of x. Generally speaking, would I be happy leaving it there? Pretty much, but I do happen to know I can take a 2 outside my bracket, which would give me cosine of x plus x sine of x, all divided by cosine squared of x. Now, again, same idea. Does that make it more readable? I don't know. Should we factorize out where we can? Probably. It's mathematical. And for those of us over here in Math Methods, we really need to make sure our notation is right, and we factorize and simplify it as much as we possibly can. Well, there we go, ladies and gentlemen. I'm done. Nice short video. Ooh, not even 10 minutes at the moment. Now, have you seen my Patreon account? I know I keep harping on about it, but if you can do anything you can to help me continue to create these videos, there's a link down there in the description that will tell you where my Patreon account is. Please go and have a look. Otherwise, subscribe. If you haven't already subscribed, click the little circly thing, the Maths Guru thing, or if you're seriously not interested, then there's a new video over there. It's been good seeing you. Thank you very much. I'll see you in the next video.